Okay, question 13. So we're given two right angle triangles made together, put together, and we're given some information. So AB is 10.4, so we'll put 10.4. Let me turn my pen on first of all. 10.4 here. We're told that the angle is 34 degrees. And the other piece of information, the ratio of AB to AD, and the first time I looked at this, I got this the wrong way around. AB, that's that length to that length, is the ratio 4 to 5. So I'm going to start by, so in effect, 4 to 5, just to indicate that there. And we're told calculate the length CD, so this is the actual length that I want to work out X. So I'm going to call this length here Y, and I'm going to work out that length first of all, and then I'm going to use that to work out X. Yeah. Okay, so if we're told, I'll come back to this ratio, 4 to 5, and we're told that this is 10.4. Then we can work out the other one. We can say, in effect, let me bring my calculator up. So I'm going to do 10.4 divided by 4 times by 5. That will give me this length here is 13. So that length there is 13. So y is going to be equal to, y is going to be the first one that I'm going to work out. So I'm just going to change pen colour, and I'm going to use that, I need to use Pythagoras to work that out. So y is going to be equal to the square root of 10.4 squared, other way around, sorry, 13 squared minus 10.4 squared, which is going to give me the square root of, and I've missed my squares out, 13 squared minus 10.4 squared, so that's going to give me, as a decimal, 7.8. Now from there, I'm going to work it out X. So using my trigonometric notation, this side here would be the hypotenuse, this side here would be the opposite side. So I'm using my sine ratio. Sine is equal to O over H, and it's the H that I'm trying to work out. So H is going to be equal to S times by, sorry, it's going to be equal to O divided by S. So X is going to be equal to Y divided by sine 34. I'm going to go to my calculator. I've already got Y in there. So I'm going to go the answer that I just worked out divided by the sine of 34. That should give me the value, well, that does give me the value of 13.94867. I'm going to go dot, dot, dot for now. And then it asks for it to 2 decimal places. So my answer to 2 decimal places is going to be 13.94. Okay, question 14. Complete the table for the complete the table of values for y is equal to 3 minus 3x minus x squared. So I'm going to use the table function on my calculator. You will be able to do a similar thing. So I'm going to type it in as 3 minus 3 times by alpha x squared minus alpha x cubed. So double check I've typed that in correctly. 3 minus 3 lots of x squared minus x cubed. So I press equals and it asks me what value I want to start at. So I want to start at minus 3 and I want to end at 1. And I want it to go up in steps of 1. And that gives me the table of values straight away. So I should have 3 minus 1, 1. And then I can use my replay to go down to the other values. 3 and minus 1. And then from there I can plot those values onto my graph. So my first point is at minus 3, 3. My second point is at -2, -1. Then we've got -1, 1. We've then got 0, 3. And then finally 1, -1. Okay, I then need to join that up with as smooth a curve as I can, and I struggle drawing these slightly on my computer screen. I would always advise keeping your wrist on the inside of the curve, and you'll get it. That's just a good tip for getting it as smooth as you can. So that's roughly going to be my curve. And then the final part, use your graph to estimate the value of, and we've got the equation being equal to 1. So to help me out with that, I'm going to draw a line at 1, because in effect that's that value there. And then I'm actually going to have 3 values here, which is quite normal for a quadratic. So I'll start off, I'm going to say that x is going to be equal to, and I tend to put them in order, smallest first. So I'm looking at roughly -2 point, well that's 5, 6, 7, 2.7, minus 2.7. My second value I can actually read off exact because we've got a coordinate at that point. So my second value would be -1. And then my third value, on my graph I'm looking at roughly 0.8. So x is 0.8. There we go. Okay, so here we've got ABCD as a trapezium. We're given some of the lengths, and we're told here we've got a rectangle. The area of the rectangle is 1.5 times the area of the trapezium. Work out the length of y, correct 2 significant figures. Okay, so I'm going to start by working out the area of the trapezium. I've got some of the information. Let's just put that on for now. So we know that A to B is 4.7. We know that B to C is 8. We know that C to D is 7.7. Okay, we need to work out this. So this, I will call this first. I know that I'm trying to work out x. Right. So to work that out, I'm going to use I'm going to have to use Pythagoras to work this missing length out. So in effect, I'm going to say that x is going to be equal to the square root of 8 squared minus 7.7 minus 4.7. That'll give me my length between there and there, that length there. And I want that squared as well. So I can, that's obviously going to just be 3, but we'll use our calculator. So let's change back our modes. So the square root of 8 squared minus 3 squared. So that is going to be root 55. And I'm going to leave it as root 55 for now. So root 55. So the area of the trapezium, I'm going to call it AT, is going to be equal to a half of the 4.7 plus 7.7 times by root 55. So again, I'll use my calculator for that. So I'm doing that value times by 0.5. That's just saves me typing in a half. 4.7 plus 7.7. So that's going to give me 31 root 55. 31 root 55 over 2, I believe that was. Let's just bring that calculator back up. Yes, okay. So that's the total area of the trapezium. When we're told that the area of the rectangle is 1.5 or 1.5 times by that. So the area of the the area of the rectangle. So the area of the rectangle is going to be equal to the area of the trapezium times by 1.5. So I'm just going to times that by 1.5. So that's going to give me 93 root 55 over 10. Right, and that is also going to be equal to that is also going to be equal to 10.2 times by y. So I'm going to put that there. 10.2 y is equal to that. So y is going to be equal to that value divided by 10.2. So if I divide that by 10.2, that will give me my actual value. So I'm going to go 31 root 55 over 34. So write it in the exact form. I'm going to go decimal now. So I'm looking 6.7618 to 2 dot 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 dot, and then two significant figures, then that's going to be 6.8. So that was the value for y. Y is equal to 6.8. Have we got a unit? We can add centimeters. Right, question 16. The table shows Mr. Andrews' Year 10 GCSE Paper 1 mock scores. So we've got our groups and draw a histogram for this information. So for the histogram, I'm going to start off by the width of the bars, so I'll call that W. I've got a width of 10 there, width of 20 there, 10 there, 10 there, 10 there, and 20 there. So the frequency density is what I need to plot on my histogram. So frequency density, which is going to be equal to the frequency divided by the width. So 12 divided by 10 is going to be 1.2. 18 divided by 20 is going to be 0.9. 11 divided by 10 is going to be 1.1. 8 divided by 10 is going to be 0.8. And that's going to be 0.5. And then finally, we're going to have 0.15. So my frequency density goes up to, my largest value is 1.2. So I need my graph to go up to 1.2. So let's just see how many squares we've got. 1, 2, 3, 4, 5, 6. Beautiful. So I'm going to go up in 0.2. So 0.2, 0.4, 0.6, 0.8, 1, and then 1.2. And I'll just mention that that's the frequency density. And then on my other axes, let's just make this a little bit bigger. On my other axes, I need to go up to my maximum value, needs to go from 0 to 80. So how many squares have we got? 1, 2, 3, 4, 5. So we're going to go up in 20. So 20, 40, 60, 80. I need to go up that far, and that's going to be labelled as my score. Okay, I can start putting my each of my histograms in there. Each of my bars in now. So my first one needs to go from 0 to 10 and has a height of 1.2. So 0 to 10 and a height of 1.2. So I'll try and use a ruler on this screen. It does mess it up slightly sometimes. So okay, that's gone quite well. My next one needs to be then 22. I've drawn my bar too wide. It should have been 0 to 10, not 0 to 20. So let's draw that again. Okay, my next bar needs to go from 10 to 30, and that has a height of 1.8. So 10 to 30, so I'm going up to there, and it needs to have a height of 0.8. Sorry, 0.9. I'm just going to put the lines in for now. Then I'm going 30 to 40, a height of 1.1. I've then got 40 to 50 going up to 0.8. So 40 to 50, 0.8. Then 50 to 60, 0.5. 50 to 60, 0.5, which is going to bring me there. And then finally, 60 to 80, and I want to go to 1.5, so that's going to go pretty much, I want to slap bang in the middle there, and then top of my bars, and I've missed off my, with my 2 bars, that should have been 0.9, so there we go. So that's my histogram drawn. Okay, work out an estimate for the fraction of students who scored between 10 and 15 marks. So I want the group that scored between this point and 45, which is slap bang in the middle of this group. Okay, so if I go back to this, so I want all of this group, and then half of this group. So in effect, that is 18 plus 11 plus a half of 8. So we're looking at 29 plus 4. So we're looking at 33. And then that needs to be out of the total frequency, which we're looking 30, 49, 49, 54, 57. So my fraction is going to be 33 out of 57. So there we go, 33 out of 57. Nice question. Right, question 17. So solve, given your answer in third form. Okay, so I am going to factorise as much as I can to start with, which I believe is only going to be this part here. So if we start that off. So this is going to go into 2 brackets. I'm hoping it follows. So x's after 2 numbers that multiply together to make 2, but add together to make -3. So that's going to be -2 and -1. Right, I'm going to times both sides of my equations now by to get rid of all of my denominators. I'm going to times both of them by my denominator of my lowest common denominator for 2 parts, which is just going to be this part. So I'm going to times by x minus 1 multiplied by x minus 2 on both sides of my equation. Okay, so that's going to give me my numerator of my first one is not going to change. I'm just going to have 4x minus 3. My second one I'm going to write as 2x plus 1 multiplied by x minus 2, because when I multiply that, these will cancel. And that's going to be equal to x minus 1 times by x minus 2. Right, let's multiply out these brackets then. So we're going to have 4x minus 3 plus, that's going to give me 2x squared. Then I'm going to have minus 4 plus 1, so that's going to be minus 3x. And then my number part is going to be minus 2, and that's going to be equal to x squared minus 3x. And this is the same as this really, plus 2. And then I'm going to take everything over to the one side and simplify. So x squared, 2x squared minus x squared is going to give me just x squared. I then got 4x minus 3x would be 1x plus 4x, so that's going to be 5x. Let me just double check that. No, it's not. 1, that's going to be 4x, so plus 4x. Then my number part would be minus 5, so that's going to be minus 5, and then I'm going to have to take 2 away, so that's going to be minus 7 is equal to 0. Giving the answer in third form implies that it's not going to factorise, so what I'm going to do now is I'm going to complete the square for this. So that's going to give me x plus 2 all squared. I need to minus this term squared, minus 7, which I've still got. So in effect, x plus 2 all squared minus 4 is going to be equal to x squared plus 4, and I've still got this minus 7. So from there I can take my number part over to the other side, so that will give me x plus 2 squared is going to be equal to 11. Square root on both sides then, so x plus 2 is going to be equal to plus or minus 11. So x is going to be equal to minus 2 plus or minus 11. Asking for two values in third form. Sorry, root 11, I missed that root off. So my first value is going to be minus 2 minus root 11. My second value is going to be minus 2 plus root 11. Okay, and then final question. So triangle ABC. Triangle ABC, side AB has a length of 8 centimeters, so AB is 8 centimeters. Side AB has a length of x, where x is greater than 0, so AD, that would be that length there, is going to be equal to x. Given that triangle BCD is not a right angle triangle, show that the area of BCD can be written in the form on, that's my form. Okay, so I'm going to work out this length here first of all, which I'm going to call y for now. So using the cosine rule, I'm going to say that y squared is going to be equal to 8 squared plus x squared minus 2 lots of 8 times by x times by cos of 60. It's going to be half, but we'll come back to that in a moment. So y squared is going to be equal to 64 plus x squared, and then I'll go for the half here, so the half would cancel with 2, so that would be minus 8x. And then I will write y down then as the square root of, and I'll just rearrange this slightly, x squared minus 8x plus 64, and that's a good hint because we're using that there. Right, so that the area of that triangle then is going to be equal to, so the area of BCD is going to be equal to, and I'm going to use the formula for the area of the triangle, so half of A times B, so that's going to be in effect y times by B, y times by 6, sorry, times, right, pens on a go slow. Right, let me just minimise and then see whether that brings it back on. Right, let me go to my backup pen, see if that's any better. There we go, and it's suddenly come back to life. I'm giving you a load of scribble. So the area is going to be equal to a half of y times by 6 times by sine of 45. So that's going to give me 3 times by y times by sine 45 is equal to root 2 over 2. So that leaves me with 3 lots of root 2 over 2 times by y, which we've just shown is that. So that's going to be equal to 3 root 2 over 2 times by the square root of x squared minus 8x plus 64, which is what we were asked to show right at the start. So there we go. And that brings us to the end of the paper. Again, a fantastic paper, a really nice paper, some good good challenging questions on there. Can't give enough credit to Maths Planner. They've produced an excellent paper there, and I would strongly recommend you go to their website and check out their other papers. Thank you very much for your time in listening. That's the website again, www.mathsplanner.com. Thanks for your time, and good luck with the rest of your revision. Final point I would just say, if you find any of those questions particularly challenging, so for example, question 16, that topic was histograms. So that's your specific revision rather than your exam revision. That will be your specific revision. And I'm sure you could link that up. I'm sure Maths Planner would have some great revision material available on there on specifically histograms if you wanted to just look at topic specific revision. Thanks very much for your time. Feel free to add any questions or comments. I'm fairly confident with most of my answers. If you spot any mistakes, please drop it in the comments. I am very mindful I make a lot of silly mistakes, so if you spot anything, please do let me know, and I will see you soon.